This is the Constellation Quarterly Report for June 2009. Constellation is America's new space program, which will take crews to the International Space Station, return humans to the Moon, and even extend human presence beyond. NASA centers around the country are working together to design, test, and manufacture hardware for this new era in human space exploration. The Constellation program has reached a major turning point as it prepares to conduct its first test flights. The rocket that will launch the crew into orbit is called Ares-1. The vehicle is composed of a 5-segment solid rocket booster for a lower stage and a liquid fuel rocket for an upper stage. The first test article of the Ares-1 is called Ares-1X. This major developmental test flight of full-scale hardware brings together the talents of several NASA centers. Sections of Ares-1X were manufactured at the Glenn Research Center in Cleveland, Ohio, and the Langley Research Center in Hampton, Virginia. At the Kennedy Space Center in Florida, rocket parts arrive by rail and by air. In Kennedy's Vehicle Assembly Building, workers carefully stack the giant components as the test vehicle takes shape. The Ares-1X test flight is a suborbital flight and will have no crew. It will ignite a 4-segment solid rocket booster with a mock-up sitting in for what would normally be a 5th solid rocket segment. The upper stage and crew vehicle are also mock-ups, carefully weighted to simulate a fully fueled, manned Ares-1 mission. Loaded with 700 sensors, the Ares-1X test flight will validate computer modeling methods. Engineers will get valuable data on liftoff, stage separation, aeroacoustic loads, thrust oscillation, and other flight dynamics. In preparation for Ares-1X, NASA transferred Launch Pad 39B from the Space Shuttle program to the Constellation program. Pad B originally was built for the Saturn V rockets that launched the Apollo capsules to the Moon. It was later adapted to support Skylab and Space Shuttle operations. Now, the Kennedy Ground Operations Team will finish modifying Pad B for the Ares-1X launch, ushering in a new generation of spaceflight hardware. Surrounding that launch pad is a highly sophisticated lightning protection system. Each of 3 new lightning towers reach 500 feet into the air, with an additional 100-foot fiberglass mast atop. This improved lightning protection system allows for the taller height of the Ares-1 rocket compared to the Space Shuttle. The crew exploration vehicle for Constellation is called Orion. Orion borrows its shape and aerodynamic performance from Apollo. However, the new spacecraft is greater in size than Apollo, featuring updated computers, life support, electronics, heat protection, and other systems. At the NASA Michoud Assembly Facility in New Orleans, Louisiana, construction has begun on the Orion Crew Module ground test article, with Lockheed Martin's first friction stir weld process on Orion hardware. When completed, the full-sized flight-like module will be tested in a variety of ground-based simulations designed to recreate the Orion flight environment. The structure will then undergo mechanical assembly, integration, and testing in New Orleans and Denver, Colorado. The Orion spacecraft will have to endure extreme temperatures, traveling from the Earth to low Earth orbit, to the Moon, and back again. The blistering return through Earth's atmosphere can produce temperatures roughly 5,000 degrees Fahrenheit. NASA studied several materials for Orion's thermal protection system, or heat shield, which will protect the craft during that re-entry process. That research led to the choice of the material called AVCOAT, which has a proven history with the Apollo and Space Shuttle programs. After re-entering Earth's atmosphere, Orion will splash down in the water, where the spacecraft and its crew will be recovered. To rehearse this scenario, a full-size replica of the Orion spacecraft has been tested for its performance in open water near the Kennedy Space Center in Florida. A collaborative effort between NASA and the Department of Defense, the test is called the Post-Landing Orion Recovery Tests, or PORT. PORT not only reveals to engineers how the spacecraft will behave under these conditions, but also gives recovery teams their first experience working with Orion. In addition, NASA will have a better understanding of the motions astronauts will experience within the craft. Other water-based tests took place in Maryland, where a smaller Orion mock-up was placed in more controlled water conditions for further gathering of data. Sitting on top of Orion is the Launch Abort System, designed to pull the crew to safety in the event of an emergency on the launch pad or in the early stage of the climb to orbit. Preparations are in full swing for the first test of the multifaceted Launch Abort System. Called Pad Abort 1, the test will include the firing of the abort motor, which pulls the Orion spacecraft from danger, an attitude control motor, which provides directional control, and a jettison motor that separates the system from the crew module. Components of the Launch Abort System have already been tested individually, but the full flight test will help gather information about how the newly developed system works together in a real flight situation. The abort motor, jettison motor, and other important components for Pad Abort 1 have already arrived at the White Sands Missile Range near Las Cruces, New Mexico, where NASA has completed work on a 92-acre launch complex. Included in the construction is a gantry steel structure, which serves as a combined launch pad and simulated launch vehicle. The gantry stands 130 feet tall and will be used in future test flights for the Constellation program. Other tests this quarter include a parachute test for the Ares 1 first stage, managed by the Marshall Space Flight Center in Huntsville, Alabama, and taking place at the U.S. Army's Yuma Proving Grounds in Yuma, Arizona. The test featured the largest rocket parachutes ever manufactured. The three main parachutes measure 150 feet in diameter and weigh 2,000 pounds each. They are designed to slow the descent of the huge Ares 1 solid rocket motor and provide a soft landing in the ocean, allowing crews to recover and recycle the stage for a later launch. Constellation is engaging the talents of engineers, scientists, and manufacturers across the country, with every NASA center involved with its development. From wind tunnel testing, to computer modeling, to parachute testing, to rocket firings, to manufacturing, Constellation is trailblazing relationships between NASA centers and commercial industry. The hardware is moving from the factory floor to the launch pad as Constellation prepares to literally take flight.